on day 2 of solving trig equations, we started on worksheet 6-7. The first 12 problems on the worksheet were review from Monday, so these weren't new, not a big deal. On the back, we did have some new things happen. If you'll notice on numbers 13, 14, 15, 16, 17, and 18, there's actually something right in front of the theta. And what we talked about in class was that the number in front of the theta tells me how many times I'm going around the circle. So what I'm going to do is I'm going to work a couple of these in case you weren't here so that you understand what was going on. So I'm going to start with number 15. So on number 15, the cosine's already by itself. There's nothing to add or subtract like what we did on Monday. There's nothing up front to divide by. All I want to know is where on the circle does cosine equal -1/2 if it goes around 2 whole rotations. So what we did on Monday is I had everyone go draw a little circle. So I'm going to do it again. And I'm going to go mark the 2 spots on the circle where cosine is -1/2. Well, cosine is negative in quadrants 2 and 3. And it's -1/2 up here at 2 pi over 3. And it's also -1/2 down here at 4 pi over 3. So if I go around the circle one time, I know that my answers are 2 pi over 3 and 4 pi over 3. So that's 2 of the answers that I have already. So I'm going to go ahead and write those down. 2 pi over 3, comma, 4 pi over 3. Now what's going to happen is I'm going to go around the circle a second time. When I go around the circle a second time, I hit both of these again, but because I went one full rotation, I have to go add 2 pi to both of these numbers. For some of y'all, this caused a little confusion. You weren't real good at adding your fractions, so as I go through this, I'll review. When you add 2 pi, you have to remember to put it over 1, so I'm going to put them both over 1. Then I have to get that common denominator. So what I want to do is make this denominator here say 3. So in elementary school, we learned that if you multiplied the number 1 by some number, I want it to equal 3. Well, that magic number is 3, because 3 times 1 is 3. So 2 over pi is the same as 6 pi over 3. So now I can go add, and I'm going to add 2 pi over 3 plus 6 pi over 3. Remember, we only add the numerators. So 2 plus 6 is 8. So I have another answer at 8 pi. We don't touch the denominators over 3. I got to go do it down here again. So same steps. Multiply top and bottom by 3. We get 6 pi over 3. So now I can go add these. And I'm going to only add the tops. And I get 10 pi over 3. So now I've gone around the circle 2 whole rotations. The first time I touched it 2 pi over 3, 4 pi over 3. I went around again, so I added 2 pi, I added 2 pi. So we're almost done. So this gives me the answer for 2 theta. I don't want 2 theta, I want 1 theta. So in order to get rid of the number on front, we're going to multiply both sides of the equation by its reciprocal. Well, the reciprocal of 2 over 1 is 1 over 2. So I'm going to multiply both sides of the equation by 1 over 2. When I multiply this left side by 1 over 2, the 2's cancel, and I'm left with theta equals. Every single radian in here has to get multiplied by 1 over 2, because whatever you do to the left, you have to do to the right. So I'm going to go multiply all the tops by 1, so none of those change. And I'm going to multiply all the bottoms by 2. So 2 times 3 is 6. So my first one is going to be 2 pi over 6. And then I'm going to have 4 pi over 6, 8 pi over 6, and 10 pi over 6. Your last step after multiplying by the reciprocal is to go reduce anything that can be reduced. And this one can be reduced. So this is going to reduce to pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. And that's how you do number 15. All right. probably need to do one more of these for you to completely get it. So I'm going to go ahead and do number 17. 17's got a fraction, and it's one of those reciprocal functions, so I have a feeling you would probably appreciate if I did that one. So on number 17, again, we do everything like we normally do. There's nothing to add or subtract. There's nothing to divide by. So then I'm just going to focus on the fact that I'm going to go around the circle 3 over 2 times. Well, 3 over 2 really means 1 1/2. So I'm going around the circle 1 whole rotation and 1/2. And I want to know where secant equals -2. Well, secant's not really on here. So what I'm going to do is I'm going to rewrite it as its reciprocal function of cosine of 3 theta over 2. And because I wrote the reciprocal word, I have to go write the reciprocal argument. So it's going to change to -1/2. So I want to think about my circle. So I'm going to draw my circle again like I did earlier. And I want to know where on the circle does cosine equal a -1/2. Well, cosine is negative in quadrant 2 and 3. And it's -1/2 up at the top at 2 pi over 3. And down at the bottom at 4 pi over 3. And we just talked about that in the last problem, so this should seem pretty familiar. The difference on this one is I'm not going to go around the circle twice. This time I'm going to go around the circle a whole time and then a half a time. So again, we're going to start off the same way. I'm going to write 3 theta over 2 equals. The first time I went around, we get 2 pi over 3 and 4 pi over 3. Now when I go around again, I'm not going to go a whole time. I'm only going to go half a time. So the only one I hit again is this one up top. So the only one I have to go add 2 pi to is 2 pi over 3. And if we just use the math that we did above, I know when I add, I'm going to get 2 pi over 3 plus 2 pi. It's going to change to 2 pi over 3 plus 6 pi over 3, which gives me 8 pi over 3. And the last thing we have to do is multiply by the reciprocal. So there's a 3 over 2 in front of the theta. I'm going to multiply both sides by 2 over 3. All the tops get multiplied by 2. All the bottoms get multiplied by 3. So I have 4 pi over 9, comma 8 pi over 9, comma 16 pi over 9, and I cannot reduce any of those. And we're done.